Nuclear power projects rarely make headlines, but what just happened at China's Xudabao plant is a big deal for how future reactors might be built, and how safe and efficient they can become. And this is the part most people miss. The real story here isn't just about one component being installed, it's about a whole new way of constructing large, complex nuclear facilities. A major modular milestone, China National Nuclear Corporation (CNNC), has completed the installation of the final module of the passive water tank inside the reactor building of Unit 4 at the Xudabao nuclear power plant in Liaoning province. This installation effectively finishes the tank as a major safety-related component for the VVER-1200 reactor design used at this unit. CNNC describes this final lift as the point at which modular construction of large components for the second phase of the Xudabao project is fully complete, after a multi-year effort. Put simply, the plant's most complex, heavy pieces have now been assembled using a highly planned, module-based approach rather than traditional piece-by-piece construction. How the passive safety system works. Here's where it gets interesting for safety. The passive water tank is part of a passive heat removal system designed to respond automatically if something goes wrong in the primary circuit, the main loop where the reactor coolant circulates. In the event of a leak or loss of coolant in that primary circuit, this system allows the steam generators to switch into a mode where they condense steam from the primary circuit, instead of just transferring heat in normal operation. As the steam from the primary circuit condenses inside the steam generators, the resulting condensate flows back toward the reactor core, providing additional cooling without relying on active pumps or operator intervention. This kind of passive safety behavior, where gravity, natural circulation, and basic thermodynamics do most of the work, is a key selling point of newer reactor designs, but it can also spark debate. Are these passive systems enough on their own, or should they always be backed by heavy layers of active systems too? What's inside the passive water tank? The passive water tank for Xudabao Unit 4 is not a single monolithic structure. It is made up of 4 large modules. Each module includes several integrated elements: reinforced concrete slabs for structural strength, stainless steel cladding to protect against corrosion and ensure leak tightness, a number of penetrations, openings for pipes, instruments and other connections, heat exchangers, and additional wall reinforcements. Each individual tank module is enormous, with a hoisting weight of about 325.9 tons, which means lifting and positioning even a single module requires highly precise heavy lift operations. When fully assembled, the completed tank incorporates 33 penetrations and 16 heat exchangers arranged within it, giving it the ability to transfer heat effectively as part of the passive cooling and safety functions. 4 years of modular construction. According to CNNC, installing the passive water tank marks the full completion of modular construction for the large components in the second phase of the Xudabao project, a process that has taken around 4 years. During this period, the project team has consistently followed a clear principle. Whenever possible, convert traditionally non-modular elements into modules, and use modular components instead of assembling everything in place. Since the first successful lift of the core shaft module at Unit 3 on November 18, 2021, the team has been pushing modular construction further, testing limits, refining methods, and turning more and more of the plant structure and systems into transportable, installable modules. This approach is not just a minor optimization. It reflects a deliberate shift in how nuclear plants can be built, which some people see as the future of the industry and others view more cautiously. The 4-in-1 heavy lift. One standout example from the project is the so-called 4-in-1 combined hoisting operation. In a single coordinated lift, the team installed 4 major components at once: the containment steel liner, through-hole components, a large steel truss, and a horizontal steel mesh. Instead of lifting and aligning each of these separately, they were integrated into one composite module and hoisted together. CNNC highlights this as a pioneering modular construction technique both within China and internationally, arguing that it significantly boosts inherent safety and quality by reducing on-site assembly complexity and potential error points. But here's where it gets controversial. Some engineers might question whether combining so many critical elements into one massive lift concentrates risk. If anything goes wrong during that one operation, far more is at stake. Millimetre-level precision. From reinforcing steel and steel liner modules to sophisticated precast concrete structures, The Xudabao team has relied heavily on digital tools and advanced analysis. They carried out extensive finite element analyses and virtual simulation optimizations to predict how modules would behave during lifting, transport, and installation. Thanks to this preparation, they report achieving millimetre-level accuracy in positioning these heavy modules, comfortably exceeding the original design requirements. That level of precision is not just a point of pride. It matters for long-term integrity, because misalignments can create local stress concentrations, complicate welding, or affect how components behave during an earthquake or other extreme event. A template for VVER-1200 projects. CNNC's number 22 Xudabao nuclear power project team now claims to have developed and proven a mature modular construction system, specifically tailored for the VVER-1200 reactor type. This means the processes, tools, and lessons learned at Xudabao can be reused and refined for future projects using the same technology. In practice, this experience could shorten construction schedules, improve quality control, and reduce certain on-site risks in subsequent nuclear builds across China. The company also presents this as a new benchmark for modular nuclear construction, signaling an intention to position China as a leader in this particular construction methodology, not just at home, but as an exporter of expertise. How Xudabao's reactor plan evolved. The Xudabao, also known as Xudapu, project did not always follow its current path. When it was first conceived, the site was expected to host 6 CAP-1000 reactors, which are Chinese versions of the Westinghouse AP-1000 design, with Units 1 and 2 planned as the first phase. Site preparation work began as early as November 2010, and China's National Development and Reform Commission granted project approval in January 2011. However, plans shifted over time. Instead of starting with all CAP-1000 units, the second phase of the project was redesigned to feature 2 Russian-supplied VVER-1200 reactors as Units 3 and 4. Construction of Unit 3 began in July 2021, followed by Unit 4 in May 2022, and their commissioning dates are currently scheduled for 2027 and 2028. This blend of domestic and foreign reactor technology on a single site is itself a strategic and sometimes debated choice. Status of Units 1 and 2 and future units. In November 2023, China's Ministry of Ecology and Environment announced that the National Nuclear Safety Administration had approved a construction license for Xudabao Units 1 and 2. Both of these units are planned to use the CAP-1000 design, bringing the original technology choice for the site back into play after the shift to VVER-1200 for Units 3 and 4. Looking further ahead, 2 additional CAP-1000 reactors are proposed for Phase 3 as Units 5 and 6. If all phases proceed as planned, Xudabao will host a mix of multiple CAP-1000 units, alongside the 2 VVER-1200 units, creating a large multi-reactor complex that combines different generations and design lineages on the same site. Who owns the Xudabao plant? The Xudabao nuclear power plant is owned and developed by Liaoning Nuclear Power Company Limited. In this joint venture, China National Nuclear Corporation holds a 70% majority stake, which gives it primary control and responsibility for the project's direction and management. The remaining shares are split between 2 other major players. Datong International Power Generation Company holds 20%, and State Development and Investment Corporation owns the remaining 10%. This ownership structure reflects a broader pattern in China's nuclear sector, where large state-owned enterprises share investment and risk in major infrastructure projects, while still keeping strong central oversight. Now it's your turn. The big question is this. Does the aggressive push toward modular construction in nuclear projects like Xudabao represent a genuine leap forward in safety, quality, and efficiency, or does it introduce new kinds of complexity and risk that are not yet fully understood? And when a single site hosts both domestically developed CAP-1000 units and foreign-designed VVER-1200 reactors, is that a smart way to diversify and learn? Or does it make long-term operation, training, and maintenance more complicated than it needs to be? Do you think this modular mixed technology strategy is the right direction for nuclear power? Or would you prefer a simpler, more standardized approach? Share whether you strongly agree, strongly disagree, or sit somewhere in the middle, and explain why you see it that way.